4.2 notes, we are going to continue to talk about a couple more good sampling techniques. Yesterday we talked about a couple of bad sampling techniques, the voluntary response technique or the convenience sampling. Okay. Today, and then we talked about one good sampling technique, simple random sample. We're going to talk about a couple more good sampling techniques that can be used, but are a little bit different than the simple random sample. They have some good qualities to them, but they do have some drawbacks. Okay? I am trying something a little bit different with today's notes, so at the end I'll ask you if you prefer it this way or if you don't. I already have the notes somewhat already written for these problems, and I have them typed up in different colors and big so that it's hopefully a little bit easier to read. I'm going to see if you guys like this or you don't like it, but I'm still going to talk about the problems and what we're talking about here today. So I might vary the notes from time to time. So in 4.2 it talks about, here it has this word called a strata. Basically, a strata, as it says here, is taking your population and dividing it up into smaller groups with like units. Okay? The reason why you would want to do a strata, okay, is to, for instance, make sure that when you're collecting data, I'm just going to grab that for you. Yeah, a little sticker on your back. So, definitely old school humor. So, anyway, when we take a look at a strata, what we want to do is break up our population into similar groups in which we might want to have representation in our sample. Okay? So, for instance, like in this class, if I wanted to just take a simple random sample of 2 students, okay, to represent the opinions of the class, I could very well have in my sample 2 boys or 2 girls. The problem that could be with that simple random sample is, girls might not be represented or boys might not be represented in the sample, and I really want the opinions of both genders. Or it could be a class where I have seniors, juniors, and sophomores, which usually happens not so much in stats, but does from time to time happen in Algebra 2, okay, where I might want to have all 3 grades at least represented in my sample. What we do is we do kind of like a hybrid simple random sample, but we do what's called a stratified random sample. So what we do in a stratified random sample is we will take samples from each of those subgroups of the population to become our entire sample that we're going to use to make judgments about the entire population. So we divide the population into our similar individuals or groups, and then we'll take a simple random sample from each group, combine all of that as one or our entire sample. Okay? So you might again say, well, why would you want to do that? Okay? Again, stratifying, what it helps you do is make sure, okay, that you include different groups, or you might get different results if you were to stratify by certain things. So in this first example here, it talks about a financial aid officer at a university wishes to estimate the average amount of money that students spend on textbook each term. They are considering taking a stratified random sample. For each of the proposed stratification schemes, discuss whether you think it would be worthwhile to stratify the university students in this manner. Meaning, does the stratification, would it actually produce different results from that of just sampling the entire population? So in A it says, your strata would be corresponding to class standing. Do students spend different amounts of books if they are a freshman, a sophomore, a junior, or a senior? Do you think books cost would be different for what grade you're in? Yeah. Why? Okay, you take different classes when you're a freshman. A lot of times when you're a freshman and a sophomore, depending on the school you're going to, you're taking a lot of your general classes that are required for the degree. When you're like a junior and senior, you're usually taking classes that are within your major. And depending on your major, you might have to buy a lot of books or not many books. I know for me personally, like when I got into my major, when I had to buy math books, it was usually just one textbook. Okay? Now this was almost 25 years ago, but you know, one math textbook would cost somewhere between 60 and 85 bucks. Okay? But like when I had to take my lit course for my literature requirement, I had to buy like 8 or 9 books, 8 or 9 novels, which would range from like 8 to 15 bucks. So it would get pretty expensive for that course. So if I was, you know, an English major, you know, some of my books could get very costly. So it could definitely vary. So what we just note here is just basically, and I'll move this up a little bit so you can see it a little bit better. So stratifying would be worthwhile because the cost of books may vary by their class standing. So as we were talking about, seniors might spend more on books than freshmen, or vice versa. You know, some courses you'd have a lot of books to buy. Some courses you wouldn't even have to buy any at all. Nowadays you have to like also, I know through my stepson, you'd have to pay, not necessarily, you could actually like rent books. You can rent the use of online textbooks, which is actually really nice, which makes it cheaper. Michael? So some colleges will include that in the tuition. Sure. Which is really nice. Do you like how it's nice and big, easy to read? I just know I have to be patient. So on B, gives you another strata. Says strata corresponding to field of study. Use the following categories: engineering, architecture, business, other. So they just give you 4 categories. Do you think cost of books and expenses would be different within the majors?
Yes.
Yeah, we actually just talked about it. I just mentioned how in my English class I had to buy a ton of books. But for my math class, I only had to buy one, given the cost of that one math book was a lot more expensive.
Okay, so this is more related to like the stuff than the material, but so when you buy your textbook and you said you could sell it back, but they would only give you like $5 or something for an $80 textbook.
Sometimes,
sell it to other students.
You could sell it to other students for more. Sure. Now, it all depends on, you know, you would have to like advertise it, so people would put flyers saying, hey, if you're looking for these textbooks, contact me. I'll sell this book for 20 bucks and this, you know, so I could buy their used textbook for $20 instead of paying $65 for it in the bookstore. All right, so again, this one, just like the last one, definitely would be worthwhile because again, the books cost would vary by their field of study. So you can start to see how you can actually start to stratify and how it can be important. But choosing your stratification needs to also make sense that there's actually going to be a difference within the subgroups. Okay. So on the last one is a good example where I'm kind of giving it away, where it's not. Strata corresponding by the first letter of the last name. So A through E, F through K, etc., etc., etc. for the letters of the alphabet. Okay. This probably is not going to be a good thing to stratify by because, letters A through E probably going to be similar to what, the whole population as a whole would give you. So doing this type of stratification would probably gain you no additional information. Okay? Again, it's very unlikely that it's going to be different than the population. Could it? Sure. There's always a possibility of it, but more than likely, this type of stratification not going to really help you gain any information or give you a better sample. Now again, just note that a simple random sample and a stratified random sample are two different things. The simple random sample will guarantee that any type of sample, all samples, have an equally likely chance of being chosen. When you stratify, that is no longer the case, okay? Because you're making sure that certain groups or people are being represented, okay? So what's nice about the stratification, you're making sure that whatever strata you choose is included in your sample. So no group or strata is left out. Are we okay with stratification and stratified random sampling? We'll have a big example on the back side here. All right, another type, okay, of sampling is called clustering, okay? Clustering is where we group or we take a sample of individuals that are near each other that have, the same type of qualities or the same type of characteristics. Okay? So one of the things that I could do in here is I could do some cluster sampling, because since I already have you pretty much all in groups of 4, if I wanted to collect a simple random sample of 8 students, I could simply take a random sample of 2 groups and get my 8 students. Okay? They have the same characteristic of being in the same class. Okay? Where you're all taking regular statistics. So if I'm asking questions about this class, a cluster sampling might be, randomly taking 2 of the 9 groupings that I have here. Okay? Cluster sampling is nice because it can be nice and convenient and quick. Okay? The downside of cluster sampling is you can leave out groups, unlike the stratified random sampling. Because if I were to pick, for instance, just looking at this class, if I were to pick these 2 groups, right here, they were selected to represent the class. What's missing? What could be missing? The opinions of boys. Here, these 2 groups have all girls in it. So we'd be missing the opinion of the boys. Likewise, if I pick these 2 groups, we'd be missing all the opinions of the girls. So clustering can leave out certain pieces of the population. That can be the downside of clustering. So you do want to try to make sure they mirror the characteristics of your population. I think that's all on this page, is that correct? Woo.
Yeah.
All right, wow, just like that, 1 page done. Okay? So, this example here just talks about, similar to what we were just talking here, You know, high school here at Hopkins High School, we assign your homerooms or your advisory by alphabetical. So, like our administration might want to collect a sample from, you know, the senior class, so he could randomly pick 3 advisory groups to be a part of his sample. That would be, okay, you know, an example of clustering. Okay. So, let's take a look at the example here and show you the differences between the 3 different good type of sampling techniques. So if we look at number 1 here, it says, the manager of a beachfront hotel wants to survey guests in the hotel to estimate overall customer satisfaction. The hotel has 2 towers, an older one to the south and a newer one to the north. Each tower has 10 floors of standard rooms, 40 rooms per floor, and 2 floors of suites, 20 suites per floor. Half the rooms in each tower face the beach, while the other half of the rooms face the street. So, this means that with the 2 towers, each having 10 floors with 40 rooms, plus the 2 towers with 2 floors with 20 suites, means there's a total of 880 total rooms. So, in question A it says, explain how to select a simple random sample of 88 rooms. So this is actually going back to what we were doing yesterday. First thing we want to do is label. So we're going to assign each of the 880 rooms. How big of a digit number should we use? 3 digits, from 001 to 880. Okay. Then we're going to use our random number table. Oh, don't let me forget. I actually printed out copies of it for you. We're not going to actually do the sampling here, but we would pick, you know, 88 unique numbers that don't repeat. And if the number like 881 to 000 pops up, okay, we would ignore it. Those 88 rooms are going to become our sample. Nick?
How do you, like when you're trying to pick these rooms, how do you know what line to look at on there? Do you just start at the first line and then go down?
Well, this one doesn't ask, all it asks you is to explain how to do it. It doesn't ask you to do it. So if it asks you to do it, it will tell you what line on your random number table. Okay, so in a nutshell here again, it says number each of the rooms a 3-digit number from 001 to 880. Using the random number table, you'll select 88 random numbers from these values, ignoring repeats, and the numbers between 881 and 000, because that would be like 1,000. Use the 88 selected rooms for your sample.
Wait, so if it just like goes past one line, you just go on the next one?
Yeah, you just keep on going and going and going until you got all of yours. Now, we're not going to ask you to do this. I would not ask you to determine which 88 rooms out of the 880 were actually sampled. That would just be so mean and crazy.
It's hot here.
But being able to at least explain this setup is what we want to be able to make sure. So notice how I'm labeling, and then I'm talking about at least how I would use the table. You don't actually have to do it because it doesn't say to actually calculate or determine which of the 88 rooms are selected. You would probably have to use half your random number table to actually do this. If you were actually doing this for an actual project, I I would probably use the random number generator even on my calculator. I don't talk too much about that, mainly because since we only spent a few days with this, just figured we'll show you one method and be consistent with it throughout the course. Alright, so this is a simple random sample. Very basic, very simple. Now we're going to get a little more complex. Explain how to select a stratified random sample of 88 rooms. Alright, stratified random sample means I want to make sure each of some sort of characteristic is represented. So if you're staying at this place, what seems to be the variable or what we're looking at when assigning numbers? What are we assigning the numbers to? The rooms. Do the rooms vary? Do they have different characteristics to them? Yeah. How do they vary? Okay, so they vary by one being old, so the south is the old one, the new one's in the north. So they vary by the location, north-south. What else do they vary by? Okay, how they face. One faces the beach, and half the rooms face the street on those main floors. Okay, or what they call your standard room. So you have standard rooms that face the beach, standard rooms that face the street. Some of them are new, some of them are old. Then what else do you have? You have the suites. Okay? And then in your suites, okay, half of them again face the beach, half of them face the street. Wow, there's a lot of different types of rooms going on here. So when I stratify, I want to make sure that when I pick my sample, okay, it's representative, okay, or it's within proportion to the number of types of rooms that I have each. So when I look here, I want a random sample of 88 rooms, and I'm actually on this one. Okay, it's still 88. How many total rooms do I have? 880. So that is 10%. So when I do each of my groupings, I want to actually take a simple random sample of 10% of the types of rooms. Okay? So if I think of these standard rooms, like for instance, I know that in each tower, I have 10 floors of 40 rooms, so I have 400 rooms. But half those rooms face the beach, half those rooms, okay, face the street. So there's 200 rooms, standard rooms, that either face the beach or the street that are in the new tower or the old tower. So I want 10% of 200 or 20 of each of those rooms. Likewise with the suites, there's 20 per floor, there's 2 floors, so there's 40 rooms in each tower, but half of those face the street, half of those face the beach, so there's 20 of each of those types of rooms. So I want to take a simple random sample of just 10% of those, or 2 of them. Okay? So I want to then combine all of that for my entire sample. So how do I go about writing that? Right? So first thing I want to do is note that since our customer satisfaction varies on the room location, we're going to take an equal proportion from each type of room. So the equal proportion we're taking is 10%. We did that because 88 rooms make up our sample out of 880, that's 10%. So I want to make sure that it's equal proportion by each type. So what that means is this. We're going to take a simple random sample of 20 from each of the 200 rooms with these 4 types. So I'm taking a simple random sample of 20 south tower facing the beach, south tower facing the street, 20 for north tower facing the beach, and 20 north tower facing the street. This gives me 80 rooms. I still need to get 8 more rooms. They're going to come from my suites. So I'm going to do a simple random sample of 2 from each of the 20 rooms with these types. So the south tower suite facing the beach, south tower facing the suite facing street, north tower suite facing the beach, north tower suite facing the street. This will give me 8 rooms. So then I will combine these 2 together to make up your sample of 88 rooms. This is about as complex as a stratified random sample problem that you could possibly see. Lots of times we'll make the stratification a little bit easier. Probably not having 8 different types of rooms. We might have 4 or 5. But do you understand how the stratification works? It is broken down. I'm not really hearing yeses. Are you too busy copying down? It is a lot of writing. Like I said, chapter 4 is going to be a lot of writing. Okay? I mean, if you want to abbreviate these, go ahead and just, find some abbreviations for it. But
For the test, we have to write like I know that we have to put all this down, but we just summarize it.
if you can find a better way to summarize it that's more concise than this, but includes all of the pertinent information you need, more power to you. Okay? I actually, when I used to write this problem, I would actually say, do a simple random sample of 20 from the 200 these rooms. And then I'd say, do a simple, and I thought, oh my goodness, I gotta see if I can summarize it up a little bit even better. So that's why I kind of did these 4 types, since they all kind of fell in the same category. Because these are my standard rooms. These here were my standard rooms. And these rooms were my suites. And it's important to be able to stratify by these different types because the opinions would be different. I don't know about you, but I'd like to be in a new suite facing the beach than facing the street. I know for some people they don't care which way they face. But hey, if I'm at the beach by an ocean, I could have a nice view of the ocean, potentially have views of the sunset right from my hotel. I'm going to take that any day. And twice on Sunday. Like I said, this example, however, is much more in greater detail with the stratification than many of the examples you would see. But sometimes we'll pick some of the harder ones to demonstrate that. So that it makes it a little bit easier. We could have made this problem half the size by eliminating, the new tower versus old tower. If we did that, then you wouldn't be stratified, you'd eliminate half of these, we'd have half the rooms. So we would make the problem a little bit easier. All right, one last question for us. It says, explain why selecting 2 of the 24 different floors would not be a good way to obtain a cluster sample. Why would you not just say, all right, I'm going to put all the floors 1 through 10, okay? Or I should say Is it 1 through 10? Or is it 1 through 12 technically? I think it's 1 through 12, right? Yeah. So I assign each of the floors a numbers 1 through 24 and I randomly select 2 of the floors. Why would that not be a good way to obtain a cluster sample? What could very well happen here? You could get 2 floors that what?
We're facing the street.
Well, if I pick a floor, will I get a street and beach view? If I pick the whole floor? So I'll get that, and I think my answer actually includes that. So I got to eliminate that. I just realized that. So it won't take care of the. I'll still get, I'll still get the beach view and street view taken care of. But what's most likely going to happen? Well, 20 of the 24 floors are what? Standard rooms. Well, 4 are only suites. Could it be likely that I get all standard rooms? And I leave out the suites? I might leave out some pretty potentially good opinions. I'm assuming that people are going to give me raves if my suites are really nice. Likewise, I have new and old. I could very well get 2 rooms that are in the old tower versus the new tower. If I had my choice of staying at a hotel that's new versus old, I'd rather stay in a hotel that's new. High definition TV in the room versus an old black and white TV. Okay, that's an extreme. Some of you probably don't even know what black and white TVs are. Have you guys ever actually physically seen a black and white TV?
Yes.
Okay, good. Someone has.
I have.
My sister used to own one and took one to college. So, all right. So ideally, what we wanted to note here is that when you cluster, you want to include all the different types of rooms within your cluster. So if you only selected 2 floors, it's likely you could get a sample with no suites or a sample from only 1 tower. That's not going to be a good representation of your population. Okay. So your sample's not going to mirror your population. So if you are going to actually cluster, if I'm looking at this hotel room, I want to make sure that I get both beachfront and street. I want to make sure I have suites, and I want to make sure I have new and old. What I might do is randomly sample 2 rooms from a floor where where the rooms are opposite sides of each other. So one faces the beach, one faces the street, and do that number for every room in each tower. Meaning, like if I selected room 107 and 108 is on the opposite side, okay? I would do 107 and 108, then 207 and 208, 307 and 308, and do that all the way up, including the suites. Do the same thing in the old tower and the new tower, and I could have that be my sample. It's a version of clustering because I really just took a random sample of 2 numbers within the floor, and I'm doing all of those room numbers. The only tricky part that I have to be careful about is doing the room numbers. The suites probably have different room numbers because there's only 20 rooms versus 40 rooms. So I'd have to make sure that if I were to pick room 30, 134 and 135, I probably don't have a suite that's, room 1134 and 1135. So I'd have to have a corresponding group of rooms that I would use for that. All right, questions about today's notes and the other 2 different types of sampling?